Thanks again for having me back for the third annual Emerging Trends Talk for Delaware Tech Forum. And thanks also for our hosts at Alpha Technologies for sharing this wonderful space tonight. And today we're going to go over some fairly mind-bending stuff at the cutting edge of science and technology. And let me first disclose that I'm a futurist. I'm not a scientist or a computer engineer. But luckily, I can explain things in a way that I can easily understand. So we'll start out with a framework for spotting trends and then go over a few recent headlines that people might have missed. So I'm a big fan of science fiction as a way of experimenting with scenarios. And a couple of years ago, a science fiction writer, William Gibson, said that the future is already here. It's just not very evenly distributed. And this is really powerful stuff if you think about it, and it raises a few questions. So if the future is already here, where does it want to live, and how can we find it? I believe that the future wants to live at the edge of things. And there are just all sorts of different edges. There are geographic edges, there are cultural edges, and there are interdisciplinary edges. But edges have edges too, and this is where we find the fringe. Looking at the big picture, there are really three broad spheres of human knowledge: biological, physical, and digital. The biological sphere is all about interactions with living things, and this started with hunting, agriculture, medicine, and beer, and these were our original cultural technologies. The physical sphere is the world of stuff, and this involves knowledge of chemistry, physics, and engineering. Now, the newest technological sphere comes in the digital world, which focuses on computation and simulation. And each of these three spheres provides a range of choices for our ongoing evolution, and we'll talk a little bit more about that later. Now, let's look at what happens when these spheres intersect and what goes on at the edges. Where the biological meets the physical, we have what's known as the real or the traditional world. And most of us have been visiting here for some time now. Where the physical meets the digital, there's automation. And we've been exploring this edge for the past century or two. And we spent some time in this zone last year at this event when we talked about the Internet of Things, wearable devices, augmented reality, and robotics. And it's all about merging the information age with the physical world. And it's happening now. The new thing is the fusion of digital technologies with the biological world. And as we'll find out, that edge is a whole lot blurrier than you might first imagine. This is what I refer to as biodigital technology. And we're just at the very beginning of this. Back in the 1950s, for example, most scientists could not see inside the nucleus of a cell. Watson and Crick hadn't discovered DNA yet. We've come a long way, but we still have a long ways to go. The most important simulation of the biological world is coming now in the form of artificial intelligence. And AI is hitting the peak of the hype cycle right now with close to 1,000 different companies doing research in this area right now. And this includes areas as diverse as computer vision, robotics, virtual personal assistants, speech translation, image processing, and natural language processing. The easiest way to get invested in AI research at this point is probably through the big three, those being Amazon, Google, and Facebook. Now, this is the year that chatbots are going to be getting a lot of attention. And you're seeing a lot of this in the recent Consumer Electronics Show. Now, most of our time now on mobile is now spent on email and messaging platforms because nobody makes phone calls anymore, right? Have you noticed that? A chatbot is an algorithm or perhaps an AI that you chat with typically via text. And it's worth mentioning that chatbots have actually been around for close to 40 years now. And there's something called a Turing test, which goes on to say that you've achieved a level of artificial intelligence once you can have a conversation with the machine and confuse it for an actual person. And one of the earliest attempts to beat the Turing test was a chatbot named Eliza, which was designed in the 1960s to emulate a psychotherapist. You'd say something, it would rephrase the question, ask you to dig a little bit deeper, and then you spend a lot of time talking about your parents, okay? Right? So Facebook is now looking at chatbots as a way to replicate salespeople for online shopping. You tell the chatbot what you're looking for, and it will make appropriate recommendations for a curated experience. Now, while Facebook is betting that we'll prefer to text with our digital assistants, Amazon is focused on spoken communications through Alexa. And you might remember Alexa as the always-on way of getting weather reports and ordering things through Amazon. And honestly, I find it a little bit spooky because it sits in your living room and then it listens to everything that's going on. And this is actually where things get really interesting. Because Amazon's Alexa was recently subpoenaed in a murder trial involving a former policeman in a hot tub. Seriously, you can't make this stuff up. There were no other witnesses, and now they are taking in the device for questioning. The lesson here is that our devices will soon be listening to us constantly. The walls now have ears. Yes, you are not paranoid, and there really is no such thing as privacy, which we will soon think of as a quaint 20th century concept. Now, another recent idea that came through was through the world's largest hedge fund, which now wants to develop artificial intelligence algorithms to make 75% of all management decisions by 2022. A few questions come from this. Will this lead to a whole new era of micromanagement? Will employees want to hang around while having machines make all the fun management decisions? And finally, will there be any employees at all, right? So futurists are now talking about something called the DAO, or distributed autonomous organizations, which serve many of the functions of traditional corporations but are run and managed by artificial intelligences using blockchain technologies. And in researching a book, The Future of Business, one thing that a lot of futurists came up with is this idea that in 10 years, your most important customer might not be a person, it could be an algorithm. And if any of you are in the search engine optimization business, SEO, you already know that, right? Because you're trying to make Google happy with your page rankings. So here's a guide to artificial intelligence in one easy graph. And I promise you that things are going to get very weird very soon. AI has taken just a long time to develop. We've gone through this long flat curve on the bottom. It's been through a lot of disappointments. And now on YouTube, you can actually listen to conversations between chatbots, right? They listen in on us, turnaround is fair game, we can listen to them now. And you'll find that chatbots today sort of have the intellectual depth of a 2-year-old, and this is changing very rapidly. You think about it, just 10 years ago, autonomous vehicles were hitting curbs and had problems yielding to pedestrians. 3 years ago, Google Images, I kid you not, could not tell the difference between a cat and a dog. And now Google can make fluid translations between dozens of different languages. True story, the logo for my business was made by a designer in Malaysia who didn't speak a word of English, and we did it all by email using Google Translate. So that being said, artificial intelligence for just a few brief years will remain in its infancy. And that actually leads me to another question, which is whether artificial intelligence needs to have a childhood of sorts. maybe AI should have a safe place where it can grow and experiment in finger paint, right? We had kindergarten, AI needs the same thing. So a group called OpenAI has created a universe of game worlds where artificial intelligence can do just that. AI programs can learn how to navigate the world, play Minecraft, explore their environment, and figure things out. And they can do it in a very accelerated fashion. Now, looking forward, the importance of gamification isn't about machines teaching us, but us teaching machines. Think about that. Now, there also might be an element of responsible parenting involved here. For example, do we need to be careful about the games that our computers are exposed to, right? Maybe we don't want our cars learning how to drive by playing Grand Theft Auto. There are better ways of doing this. Now, the easiest way for AI to learn how to play a game is by programming something called a neural network. And this is a simulation of what goes on inside of our heads, and these are both neural networks. One happens to be digital, the other one happens to be biological. And on the left side, you have sensory inputs, and on the right side, you have outputs or decisions. In the boxes in the middle are neurons, or sets of rules that can be used, while the lines connecting them are axons or dendrites. And this is how Google learned how to translate better. Another approach is something called a genetic algorithm. And as we know, ideas are inherently promiscuous. They like to go from one person to the next. And if you put two really good ideas together, sometimes you get a third idea, which can be evaluated and tested. Successful ideas are then recombined to have kids of their own, and these are becoming the facts of digital life. So the new thing at this point to come out of deep learning is something called generative design, which involves giving AI a set of constraints and then letting it build things. These were actually designed using Autodesk's Dreamcatcher software. And the results are often very organic looking and in many cases use considerably less material than designs made by actual people. Here we have an AI designed bicycle stem, a bolt, and an engine block. And these are all great applications for additive manufacturing or 3D printing, which we've talked about in the past, because you can't produce these objects using traditional tools and techniques. Once you dig a little deeper, you realize that nature also uses really good design. One example is Toyota, which was looking to build an aerodynamic car 15 years ago with a low surface to volume ratio. And nature had already solved this problem and designed the boxfish, which was then used as the inspiration for the Toyota Prius. Another great example of natural design is DNA. Digital code is binary, just ones and zeros off and on. Genetic code is similar, but a little more sophisticated. It's technically quaternary and uses 4 building blocks instead of 2. These include adenine, thymine, guarine, and cytosine. I had to have my wife fact-check that one, by the way. What's interesting is that engineers have been able to store information and, in fact, write entire books using DNA strands. It's a very dense and very stable storage medium that can retain information for thousands of years across a broad range of temperatures. A single tablespoon of DNA contains more memory and information than all of the iPhones in the world put together. So to extend this comparison a little further, scanning for malware on your computer is a lot like running a test for genetic abnormalities. And the goal here is to find all the wrong code in all the right places. This is something that we learned from John Cavazos from University of Delaware at the last Tech Together. And we're going to need all of the information that we can get, because even after 15 years of sequencing the human genome, we still don't know what it all means, because it's really, really complicated stuff. Getting better at coding might make us better at understanding how the world really works. So there are three big challenges in bioinformatics, and artificial intelligence is going to be a huge help here. So the first area is in making sense of sequencing. We've been able to read the human genome for 15 years, but we still don't understand what much of it means. And what physicians are learning is that many types of pharma treatments may or may not be effective depending upon the patient's genetic markers. And it makes sense to have a $1,000 genetic test first to determine if a $5,000 drug treatment is going to work or not. And this is going to provide some huge savings for healthcare. The second big area is the microbiome. How many of you have heard of this? Okay. 10% of our body weight is in the form of bacteria, some of which is inheritable. And that means that I'm carrying around 20 pounds of the stuff, and it sure would be useful to know what it's doing. So if you have a serious infection such as C. diff, your doctor might recommend a transplant of gut bacteria to improve your body's immune system. And what they found is that your weight and, to a certain degree, personality can be influenced by the donor's bacteria, right? And this is really crazy stuff. Finally, only 3% of our DNA is directly involved in manufacturing proteins. The other 97% seems to be telling the other 3% when to be doing something. And this opens up the whole area of epigenetics, or understanding when and how environmental signals trigger genetic responses. So, looking at the future of biotech, two things just keep coming up again and again and again. The first is pigs. The second one is China. So 15 years ago, Craig Venner was credited with sequencing human DNA for the first time. Now he and his company, Synthetic Genomics, is working to develop pigs that are humanized to create biocompatible organ transplants. Your body recognizes an unmatched transplant organ, such as a heart, a kidney, or a liver. And this is triggered when foreign proteins are identified, causing a chain reaction in which your body attacks the newly transplanted organ. This leads to organ rejection, sometimes death. Now, in this case, scientists have succeeded in removing the proteins from pig cells that are most responsible for rejection. So that means the pig parts on a cellular level are coming close to indistinguishable from human parts. And the current focus for synthetic genomics is developing lungs for human transplant. But there are other alternatives coming out as well, including three-dimensional bioprinting, which is currently used to make liver tissue and bladders. So now for $20,000, your dog can have a new bladder, right? This is a real thing. And if you really want to look at the cutting edge of bioscience, take a look at what the veterinarians are doing. They know more about stem cells than anyone. Meanwhile, BioStage has a competing technology that uses a bioreactor or artificial womb to grow new organs from patient stem cells. On the cover of Scientific American this month, there is an article on organoids, I had to get this one, or artificial brains that scientists are developing from stem cells to study Alzheimer's disease. Now, the real challenge for synthetically grown organs is the problem of introducing vascularity or blood flow. So in this case, scientists can only grow human brains that are equal to that of a 3-week-old embryo. So it's still really, really early. But it's all crazy stuff, okay? Now, I'm a money guy, and when I look at this sort of thing, I wonder, how do companies raise money to do this kind of research? And some of it's going to come from grants, some of it's going to be VC funding, others might have a bake sale. But in China, they decided to have a fundraiser by selling the world's first genetically modified house pet, which of course is a micro pig. And at adulthood, these weigh about as much as a medium-sized dog, and they're very, very smart and trainable. It's also possible to select your micro pig's color and pattern. You can custom make your micro pig, and they typically run between $1,000 and $2,000. So now pigs are people too. And the genetics of a human being are remarkably similar. Pigs are just one branch away from us on the family tree. So last April, a different Chinese lab used CRISPR technology to edit 213 human embryos. It's already starting. And what they did is they inserted genes to create HIV resistance and then published the results in an academic journal. They succeeded with 4 embryos, with the remainder containing either the original genes or unexpected mutations. And similar experiments are happening now in Sweden and the UK. And it's all just very controversial stuff. In principle, tweaking our genetic code for better health kind of sounds like a good idea, but I think it's sort of worth having some public discussion first, and I don't have a lot of confidence that we really know what we're doing yet. So to wrap things up, there are really 3 plausible directions for human evolution based on our technology preferences. The first would be pure biological evolution via natural selection or genetic engineering. The second would be more of a cybernetic approach using embedded devices, exoskeletons, etc. And this is really a symbiotic merger between man and machine. Digital evolution would involve uploading our consciousness up, perhaps onto the Amazon cloud, where copies of ourselves could live forever in a virtual reality simulation, or at least as long as someone's willing to pay the electric bill. But there's a fourth option, which I think is worth considering and is perhaps the most appealing. Let's call it an evolution of the human spirit. As French anthropologist and theologian Pierre Teilhard de Chardin once suggested, human evolution hasn't stopped, it's simply moved inside. And as we develop AI, we have to remember that AI will become a reflection of who we are. So thanks for having me today. I think there might be a few questions. This always tends to stir up some interesting conversations. So, yes.
One thing that I was sure you were going to mention about the genome is the up-and-coming technology of CRISPR, because of the ability it gives the scientists and the engineers to modify the DNA on almost molecule-by-molecule basis.
It's sort of word processing the human genome, and it's a really big deal. I mean, there's CRISPR, there's TALENs, there's a few other technologies, and that's what they're doing in the editing that they're doing now. Now, there's also some research coming out of the University of Delaware, which is like error checking that word processing, or like spell checking, which I think is going to be really important stuff too. So, yes.
You referred blockchain.
Just briefly, yeah.
What do you think blockchain will play a role in coming technology, right from investment banking, retail, insurance sector?
It's really big. It's huge, actually. I think that blockchain may be one of the most important technologies to come out of this decade, and maybe one of the more important technologies for Delaware as well, particularly in the area of what's called fintech or financial technology. So what a blockchain is it's a distributed ledger that enables multiple people to have copies of the same transaction in a way that's very difficult to hack. Because when you're hacking the blockchain, you have to hack thousands of locations at the same time, and it's really, really hard. So one of the applications coming out of blockchain, a lot of people are familiar with the Bitcoin at this point. That was sort of an early trial of it. Going down the road, you have the potential for smart contracts. You also have a potential for very quick overseas transfers and transactions with copies of everything available for everyone to see. So I think it's important. We're going to be developing it over the next 10 years, and any company locally or abroad that develops a degree of expertise in the blockchain is going to have a great advantage. So yes, Eric, yeah.
So I always love how positive you are.
Thank you, yeah.
But there's been concerns raised around, say, the artificial intelligence question. Didn't know if you wanted to give your comments or thoughts around some of the possible negative.
Yeah, well, it gets spooky. And I have a whole other talk about the future of work in which artificial intelligence is beginning to replace cognitive labor in many cases. Whether you're looking at what's going on in the investment management industry or you're looking at what's going on in writing and publishing, a lot of that's being written by bots at this point. One of the most interesting concerns was raised by Elon Musk regarding AI and automation. And he expressed worries that we may be used by AI as sort of the boot program to make technology possible, right? And if you really sort of process on that, it's a little disconcerting, but that's something worth thinking about. Yeah. Mm-hmm.
What are your feelings on universal basic income or universal guaranteed income for those displaced by AI eventually?
Possibly coming. There was actually a really good discussion of that in the MIT Technology Review last June, because it's estimated that 30% of all jobs may be displaced by artificial intelligence in some way, shape, or form. So you could have higher levels of sustained unemployment. So the question is whether there should be a minimum wage, as it were, or more specifically a negative income tax, where kind of everyone's receiving some kind of benefits. And really what the consensus is that we need a lot more productivity made possible before that becomes feasible. So we may have that sort of universal income possibly by 2050, but not within the next decade or two. Although some countries are experimenting with that now. Mm-hmm. Yes?
Do you think the humans are going to know when the AI takes over the humans? They're going to know. And the AI...
They're taking over my Amazon account, and they're taking over my Netflix queue right now. It's kind of interesting, actually, because Amazon is investing a huge amount in AI, and Netflix is as well, and we're sort of in this golden age of television now that nobody watches television anymore, because they know what goes into a good story, right? And that's kind of interesting to watch. But I think it's going to come in bits and pieces, but it's going to come first for, I think, convenience, then security, and then for cost, right? So AI is to the cognitive professions to what robotics is to the physical professions. Yes, John?
Yeah, on the biological and the data merger, one of the things that we know about happening right here at UD is they're developing organ models that are based upon how organs function, and it can accelerate the whole drug development process, because it can basically simulate to some fairly exacting standards how drugs might work in the human body, both as curative but also maybe as metabolized, that sort of thing. That's kind of fascinating to me. And also you talked about 90% of our genome is sort of like telling the rest what to do. Well, there's a lot of cancer advances in oncotherapeutics that are now looking at part of the basis of some cancers is whether whether certain genes are actually turned on or turned off. It's called upregulated and downregulated, and how you control that. And a lot of the drugs that they're developing now are really based on turning on and off certain genes so that they can, slow down the advance of cancer, which, by the way, cancers might have its own sort of form of artificial intelligence and how it changes from one to the next. And part of the way we're trying to combat that is we're trying to predict where cancer is going to head when you hit it with this whether it's chemotherapeutic, radiation, or whatever it might be, try to predict where it's going to go next so you can kind of head it off at the pass. And that's using artificial intelligence.
Awesome.
Yeah.
Awesome. Good stuff. Thank you. Great. Yes.
How about unintended consequences of technology? And I don't know if this story is true or it's a rumor going around, but someone had a Lexus, and their child ordered a toy or doll on a Lexus, and it showed up, and the parents didn't know about it. And then the news did a story on it, and everybody listening to the story, their Lexus was listening, and they heard the phrase "order that toy." Now, I guess people ordering that. What do you think about the unintended consequences and insecurity, and how is that going to keep up with this technology?
It sounds like the golden age of advertising to me, right? So there will. So we're learning this all as we go along, I think, is the bottom line of that. In terms of maybe there are some things that you can and cannot say within an advertisement. One of which might be Alexa, please order me a $300 pencil, right? So, great. Well, I think that kind of wraps up the formal conversation for tonight. We'll be mingling and talking a little bit afterwards, but thanks again for coming out.